Hi, welcome to Madcom. In this particular video, we will be discussing one important question from NCERT Science, Class 10, Chapter Electricity. The question is given in the textbook. So we will be seeing the detailed explanation how we can proceed that particular question. Before going to the question, as a token of gratitude, please like to this particular video, subscribe to our channel, share with your friends, classmates, teachers, relatives. So we'll go to the question. The question is, an electric lamp of 100 ohms and a toaster of resistance 50 ohms and a water filter of resistance 500 ohms are connected in parallel to a 200 volt source. That means we have a battery or a source which is providing a potential of 200 volt. There are three devices, one electric lamp, one toaster, one water filter is connected in parallel to this particular device. What is the resistance of the electric iron connected to the same source that makes as much current as all the three devices, all the three appliances, and what is the current through it? That means they are telling that whatever it may be the current which is flowing through these three apparatus or these three appliances, that same current will be flowing through the electric iron box. Now, the first, if you're considering that we have a 50 ohm source, sorry, 220 volt source. So this is the 220 volt source. This particular 220 volt source is connected to three devices. So this is device number 1. Then we have a device number 2, and we have a device number 3. So the three devices are connected in parallel. This is D1, D2, D3 are not standard notation. This is for just an understanding. Okay. So three devices are connected in parallel. The resistance offered by the first device is 100 ohms. The resistance offered by the second device, this is 50 ohms. And this resistance offered by the third device is 500 ohms. 500 ohms. We know that when three instruments are connected in parallel, in a parallel connection, the voltage or the potential difference remains constant. That means the potential at the D1, potential at the D2, sorry, potential across D1, potential across D2, potential across D3 would be same. Then what is different? In the case of a parallel connection, current varies. For example, if I amount of current flows through this particular circuit means, if this device is getting I1 current, this device is getting I2 current, this device is getting I3 current means, the total current I will be equal to the sum of I1 plus I2 plus I3. So the total current will be the sum of the current which is flowing through three individual devices. Done. In a parallel connection, the voltage remains constant. Since the voltage remains constant, V will be a constant. So the V value, that is V will be equal to V1 equal to V2 equal to V3, that will be equal to 220 volt. So the voltage will be equal to 220 volt. We know that according to Ohm's law, V is equal to IR. According to Ohm's law, V is equal to IR. That means if you want to, or if you are interested to calculate the current across, if you want to calculate the current across each instrument means, we can write it as V is equal to I1 R1, that will be equal to I2 R2, that is equal to I3 R3. Why? Because the voltage remains constant. Current into resistance will give you the voltage. So if you consider the first device, we know that the resistance R1 equal to 100 ohms. The resistance R1 equal to 100 ohms. And we know that the voltage is equal to 220 volt. The voltage equal to 220 volt. If the voltage equal to 220 volt, so the current I1 will be equal to V by R1. Current I1 will be equal to V by R1. That means here the voltage is equal to 220 volt. Voltage 220 divided by the corresponding resistance is 100 ohms. Why? The resistance through the first device is equal to resistance offered by the first device equal to 100 ohms. So 220 divided by 100, that is equal to 2.2 ampere. That means the current which is flowing through the first device, which is offering a resistance of 100 ohms, will be 2.2 ampere. In the same way, if you are trying to calculate the current through the second device, that is I2 equal to V by R2. Why we can take V? The reason is that since D1, D2, D3 are connected in parallel, since the devices are connected in parallel, the potential remains constant. So here the potential will be equal to 220 divided by what is the resistance? Resistance equal to 50. On cancellation, 22 divided by 5. 22 divided by 5, that will be equal to 4.4 ampere. 22 divided by 4, that is equal to 4.4 ampere. Clear? The same way, if you are calculating the current across the third instrument, that is I3 equal to V by R3, that will be equal to 220 divided by 500. Correct? 220 divided by 500. So 0, 0 cancel. 22 divided by 5 is 0.4 means 22 divided by 50 will be equal to 0.44 ampere. 22 divided by 50 will be equal to 0.44 ampere. So the total current which is flowing through all the three devices, that will be equal to I1 plus I2 plus I3, that is equal to 2.2 plus 4.4 plus 0.44. That will be equal to, this is equal to 6.6 plus 0.4, that is equal to 7.04 ampere, approximately written as 7 ampere. Here, as per this particular question, there is no requirement to calculate individually the current through each device. But in order to make you understand, if the question is asked you to calculate the current flows through individual device, now how we can proceed, that is why I individually calculate I1, I2 and I3. Otherwise, what you can do it now, we know that I1 is equal to 220 divided by 100. I2 is equal to 220 divided by 50. I3 will be equal to 220 divided by 500. So the total current I will be equal to I1 plus I2 plus I3, that is equal to 220 divided by 100 plus 220 divided by 50 plus 220 divided by 500. 220 divided by 500. So if you take 220 divided by 50 common outside, you will get 1 by 2 plus 1 plus 1 by 10. Correct? 1 by 2 plus 1 plus 1 by 10. This is equal to 22 divided by 5 into, in order to make the numerator same, here multiply with the 5. So you will get 5 by 10 plus 10 by 10 plus 1 by 10. That will be equal to 22 divided by 5 into 15 plus 1, 16 divided by 10. That is nothing but equal to 22 divided by 5 into 8 by 5. Correct? 8 by 5. So on cancellation or on simplification, you will get 22 into 8, that is equal to 136 divided by 25. This will be equal to 7.04 ampere. So you can get the same value as current is equal to 7 ampere. Now the question they are telling that same amount of current is passing through an electrical iron box. So then what would be the resistance? So in that particular electrical iron box, the current is equal to 7 ampere. If the current is equal to 7 ampere, the potential is same, that is 220 volt. The potential is same, that is equal to 220 volt. Then we can calculate what R is equal to V by I. So that will be equal to 220 divided by 7. 220 divided by 7 will be equal to 31.25 ohms. 220 divided by 7 will be equal to 31 point, approximately if you are taking it as 7.04, you will get 31.25. If you are taking it as 220 divided by 7, if you are exactly taking your approximate value, if you are taking now, it will become 31.43 ohms. Okay, any value you can take it. So this is the way in which you need to proceed this particular question, because the three instruments are connected in parallel. That means voltage remains constant, current varies. So we have calculated the current flows through the individual devices. So we have taken the net sum. That current will be flowing through the another device. So we have calculated the resistance offered by that particular device when the potential as well as the current is stored. Hope the explanation is clear. If you need any further clarification, do let me know in the comment section. As a token of gratitude, please like to this particular video, share with your friends, family members, relatives. Keep watching, keep learning. Thanks for watching. Bye.